going to make a video about one of the array sorting algorithms called selection sort. Now I'm using C Shell, which is the computer science interface for UWaterloo. And let's begin. This is in C, and we're going to sort arrays. So firstly, we want to include the standard io.h file so that we can have commands printf, and it also gives us scanf, but we don't need it for this. Now we want to have a main function. Our main function always returns an integer to the system. For the status code, it's going to be our main. We're going to void, so it doesn't consume arguments. And yeah, okay. So the basic definition of an array, we can call this starting array A, and let's make it a array of size 6. So there's 6 elements here. I'll just try to randomize it a bit. 3, 10, 6, 7. I think that's good enough. And it's always good to just add the length somewhere. So I'm just going to add the length. And that is 6. And I'm going to pass this into a function I'm going to create, which will be called selection sort. And I enjoy, yeah, we're also going to pass the length, because when you pass arrays into functions, you can't really find the length. And using size of is not apparently the best way to do so. So we'll pass length as well. So now so let's define our function here. So we won't even return something. I have a better plan. Selection sort. And let's take in an array, arbitrary array, and a length of the array. How about we write array length? Yeah. And let's start writing our function. What I want to do for this function, let me include some documentations. What I want to do, so my purpose is to sort and print out. I want to iterate over this whole thing and print it out nicely in a way like A, B, like if A and B were all the elements in the array, C and then a full stop or something like that. So I want to do, yeah, basically that. Let's start with the algorithm though. So we want to, the idea is that we have these 6 positions, right? And this is position 0, 1, 2, 3, 4, 5. We want to go over each position and find the smallest integer in the whole array for each position. Now, after we find the smallest integer for the first position, which is this is the array we want 2 to be the first element. And then we're going to go put 2 in place of 5. So we're going to have 2, 5, 3, 10, 6, 7. And that's one of the implementations of the first position. And then we're going to go into the second position, and we're going to find the smallest digit after it and figure out there is a smallest digit, and if so, we want to swap it with this one. So we can put it here. Now, same thing here. Now, this position might be a little more difficult because it's you have to skip over two different positions technically. Actually, no, never mind. We go through this one, we go through this one, and we will go through this one. First, we figure out that um, nothing is in this position. Then we're going to go to the fourth position. And when we go into the fourth position, we'll see 6 and 7. So first, we're going to see 6. So we're going to swap this. But our algorithm is going to keep continuing, but with the 6 itself. And it's going to check if anything is smaller than the 6. That's basically how the algorithm works. My example might have not been the best demonstration of the more complex part, but I think you notice in the implementation how this happens. So I'm going to start with a for loop because we want to iterate all over the list. I'll start with an integer I, and we'll set it to 0 because we're 0 indexed. I is going to be less than the array length, so we can go over the whole array, and we're just going to increment I every time. Now, if you're not sure of this notation, I can also write it like this. And hopefully it makes more sense to look at. And now, as I mentioned, once we're in this position, we want to find the smallest one. So we want to go over the whole list again. So why not make another for loop? So when we're sorting the first position, we're going to have 2 in this position, okay? That's ideally how sorting works, because we're going to sort in an ascending manner. So we don't have to go back to this one position. And we shouldn't go back to this position because it's already sorted. So we always want to start from the position that needs to be sorted and then look at the rest of the list. We don't want to go look at the whole list every time. So what we're going to do is we're going to create a new integer. We can call this j. We can set it to equal the position we're currently at, right? Oh, I'm ruining these for loops. Excuse me, gotta use semicolons. And yeah, we're gonna set it to equal that position. Now j is also has to be less than the array length, because we can't exceed this length, because C is not able to distinguish the length of the array itself. And we increment j. Now each time, what do we want to do? Well, essentially, we want to see if the position in the if like the value in the array of position I is essentially bigger than j, and if so, we want to swap it. Now you could also I guess make if statements, but I think the best implementation is, I meant multiple if statements, but the best is just to have one if statement. Say that array, so we want to get the value of the array in position I. We want to see if it's going to be greater than, because this is an important case, because we only want to change something when something is greater than. So if 5 is greater than 2, So we want 2 to be the new value that we're looking from towards the rest of this list. So if array I is greater than array of j, then what do we want to do? Essentially, we want to swap these values. Swap these values. We want to swap this and this. Now to swap, if you guys didn't know, we got to use the address operator so that we can pass this to a function and actually mutate these values. So I'm going to pass it into the function. I'll write the function right after. Okay, so we have this. Now, I realized one thing right now. Technically, we do not need j to equal I. So we do not need to look in the same position because essentially we're just looking if, example for the first iteration, if 5 is greater than 5. Just pointless. So I'm going to change that to I plus 1. And hopefully that makes sense to you too. We're going to swap, and if it's not, well, it doesn't matter. We're just going to make sure that nothing else is smaller than this one value, correct? Now, I guess before implementing print, we want to figure out how to swap these values. Now, swapping is a very simple thing. If you know how to use address operators, you don't want to return anything in this function. We will say swap. We'll take in 2 pointers, int p and int q. Sure. We want to make a variable that can store the value while we change the other one. In temporary is just going to be the value of p. Now we're going to change the value of p to be the value of q. What is this? Value of q. And then we're going to change the value of q to just be temporary. Now that should swap it out. We can also test it really quickly if we want. So we can just say printf d let's print new lines as well. Let's say p, and let's do q over here, and we'll print out before and after. Now this might be a complete function, so I think we can even test it now. So I'm just going to comment this stuff out, and I'm going to just make 2 new integers really quickly. I'm just going to test it on regular integers, and then we're going to swap a and b. Well, we need to send in the pointers, don't forget. So we're going to send the address in, and let's run. Okay, we see that. What is this error? I think type specifier missing. Oh, yeah, we just need to add integer for the length. And yeah, we can see that they swapped. So our swap function is working. Normally you'd want to test it a bit more, but if it works, it works. So now let's print. So want to make sure we're out of scope from this sorting system. Now we just want to print this array that we have, that we've created and mutated all its values so that you sort your list out. How we'll do this is make another for loop. This is going to be very easy. We're just going to say p for print is 0, p is less than the length, so array length, and then we're just going to increment p, and if p is not equal to 0, then we can have this. You can just print it like this with a comma, space, format specifier, print out array of p, right? Otherwise, p is probably going to be let's go 0. So in that case, we just want to print it alone. Want to print array p again by itself, and since we want to make it a bit fancy, let's add our clause that let me first just write what we need to add. We just need to add a full stop. Let's add a new line as well, just to make it nice. And this is in my else scope. This is in my scope. I don't want to print this until this whole thing prints. I just want this to be the last thing and print only once. So how about we try this now? Hopefully it works. A few errors. Let's see what these errors are. I redefined p somewhere. And what is this error? Oh, I did not put this here. Oh, I missed another one here. That's annoying. Oh, my for loops again. I used commas. Should work now. There we go. We have sorted this array. And we should probably get rid of this swap code. Just gonna make our interface look very messy. How about we try one more example just to make sure this code is actually working. Let's try an odd number now. Now we have to actually, just one thing to point out, that we need to require that. I'm not sure of my implementation, but I think that this array must be of length 1. I may be wrong, but it's always better to be safe. And let's just do 3. Let's make, I don't know, 8, 7, 39. Sure. And let's just selection sorted. And we'll manually put the length to 3 because we can do that too. And let's see, 7, 8, 39. That looks good to me. We did it, I guess. Thank you for watching. Hopefully that was helpful. If you have any questions, then feel free to write it in the comments.